Hi guys, so today I'll be telling you about VPC and what is a VPC. VPC is just a virtual private cloud on your AWS. What it means is it means that all the resources, all the things that are the resources in your AWS that you're deploying it are being deployed on VPC. That is your private cloud, private network or private network server in which all the AWS resources are being deployed to. So that is what a VPC is. So by default, if you create a new account, you'll all be working on a default VPC that is being provided by AWS only. Also, VPC is like I'll show you. So this is your AWS, and this is your AWS cloud, and inside this you have your own VPC, virtual private cloud. So this is your own VPC. This is you can create on your own also, and inside these all the AWS services are being deployed, and all the AWS services which are deployed are in belong to a particular VPC that you could see on each AWS resource description. Now inside this VPC, the full form of this is virtual private cloud cloud. Now, what it does is it gives you a overall what we can say control over all the services that you're doing. Supposedly, there are two, three services or two, three instances in your AWS, and you want to have so what if you have your own VPC? What it gives you is it gives you control over all the services that are there running in your AWS. Now there are several components of a VPC. A VPC have like if you go for a default VPC, all the components are by default will be there in your pre-made by the AWS. But if you don't, if you have to make your own VPC, for example, every company or every big organization has their own VPC, and they deploy all their resources in that own VPC. So that what it means is they have their own control over the all the resources that are there in the VPC. Now let's go for components of VPC. What VPC consists of? Firstly, VPC have these IP address ranges. IP address ranges. What it means is it is being defined with a CIDR block. Now, a CIDR block, you could see a IP address by the name of 192.175.0.0 and slash you could see anything slash 32 or slash 16 or slash 24. So these all individual are what known as octet. Now these are octet, and in each octet it is of 8 bits. I am right now telling you about IP address so that you could have an idea about how CIDR block describes all the IP address in your VPC. Now these each octet that you could see here 192, it's completely it's individual 8 bits. 8 bits is like individual, it is consist of 8 bits each octet. Now after this, once you see, now you have to give a range to your VPC, so that what IP ranges in VPC means is how many devices or how many different servers you could run. Supposedly your IP range, how you could supposedly your IP have, supposedly this is your VPC IP address range, or this is your 10.0.0.0 slash let's say 32. Now what it means is that you are providing only uh, one IP address to connect to your VPC. Now how do you give your CIDR? So ranges is CIDR range. Now for every VPC you have to give a particular CIDR range, so that it could define how many IP addresses can connect to it. So what it means is supposedly this is what you give your VPCs as a CIDR block slash 16. What it means is all the last three octet slash 16 means each octet it has 8 bits: 8, 16, 24, 32. Now slash 16 means all the last three octets could have been could say could be used to give IP ranges. So the first IP range that you could see here is 10.0.0.1 slash uh, 30 slash 24, or you could see anything. Now what it means is the first, this is the first IP range. After that, the last IP range would be 255.255.255. So in your VPC you are providing that from here till here these many IP ranges can be provided by the VPC. These many IP ranges or these many IP addresses can be provided by the VPC. Now how do you calculate how many VP addresses provided is 10.0.0.0 slash 16. What it means is last three octets are empty and we could use it. We could use them. Now, how do you know how many IP addresses are defined? So it means is there's a simple formula to calculate the IP addresses. So total is 32 bits. Now 8, 8, 8, 8. So 8, 16, 24, 32. Now if you have to calculate the number of IP addresses, what it means is 32 minus 16. So it gives you what 24. So six, oh sorry, it don't gives you it gives you okay, sorry, I'm weak on maths. So okay, so it gives you 16, 32, 16 plus 16. Okay, sorry. So now this is your IP address, CIDR block of VPC CIDR block that you have provided. Now you want to know how many IP addresses that you could provide in this. What it means is 32 minus 16. What it gives 16. So 2 to the power 16, which is around 65,000 something. So this is what your IP address. So this is the maximum that you could give a range to your VPC, and the minimum range is just slash 24 is the slash 24 is the minimum range that you could provide to your VPC. Now these many IP addresses you could provide in a VPC. Now that you know that your VPC CIDR block is this, and you slash 16, and now you could provide 65,000 something IP addresses in it. So all the services that you run inside and all the things that you do inside, so it is like a big network of IP addresses, and so many things can accumulate inside these so that it could provide IP addresses to so many things. So this is all about the CIDR block and how many VPCs or how many IP addresses you could give inside a CIDR block. So now when you create a VPC, you have to specify the CIDR range. Now supposedly you create a VPC and you provide this CIDR range for your VPC. So what it means is, that is what I was telling you. It means that you could provide 2 to the power 16, which is equal to something 65,000 something. So you could provide these many IP addresses are available inside your VPC. Now, where does this IP addresses go? These all IP addresses goes to all the services and everything that you run inside your VPC are being provided the IP addresses under this range. Now, this is your VPC. Now inside that, also the VPC is like region. It is bounded by region. Now there are so many regions in AWS. Suppose US East 1, US East 2. So now you could create VPC as many as you want in each region, but AWS have a limit of provide US East 2, US West 1, like that. Now, AWS in one region, you could make as many as 5 VPCs that are in your AWS. It gives you access to make only 5 VPC. One is by default is there, and you could make 5 VPCs in total in each region in your AWS. However, if you want to increase the range, you could even tell the AWS or request the AWS to increase your limit. So it could get increased. Now it is region specific. What I mean by that is, supposedly you have your VPC in US East 1. Now, in your US East 1, there are so many regions like US East 1A, 1B, 1C, 1D, E, F. So there are six regions that are available in US East 1. So what you could do is you could make a VPC in US East 1, and inside that you could make all the availability zones, all the AZs can be provided, or in all the inside US East 1, all the availability zones could be specified. What I mean by that is, supposedly you're making a VPC in US East 1, VPC US East 1. Now there are so many, yeah, like 1A, 1B, 1C, 1D, 1E, and 1F. These are all the AZs that are available in US East 1A. Now you make your VPC, and inside that you have to make subnets. Now what subnets is, supposedly I'll tell you what about subnet. So subnets are basically different, is a way to partition your servers. Now what it is supposedly you have a web server which have a front end to it, front end. Now this front end is what is being is public facing, like public facing. And what it means is you could see the UI and everything of this front end and all these things. So this web server is running on EC2. Now this EC2 is being public faced. What it means is it is having the internet access, and it is internet facing. Internet facing. Now this EC2 could be launched there, you could be launched in this public subnet. Now we could have public and a private subnet in VPC. Now it's not specific that you could have only one public subnet or one private subnet. You could have as many subnets as you want in a VPC, but that totally depends on you. It's to make it generic and more aggregated, or to make a essay. So what we used to do is we make one public subnet and one public subnet and one private subnet in each AZ. What it means is, in 1A I am making two subnets, one public, one private, in 1B, 1C, 1D, 1E, 1F. Now all the things that are internet facing, or all the EC2 instances, all the EC2 instances which are internet facing, I could launch those EC2 instances in public subnet. Now in this, all the EC2 instances, all the web server things could be stored. Now there must be some data that is getting stored in this, which is data server. Now this data server is like private, all the access, all the data access and everything. This data server must be running on some EC2 instance as well. But what you want is, you don't want people or the internet to have access to this. So what you could do is you could launch it in a private subnet. So in a private subnet you could launch the private EC2 instances, or so that this subnet will not have internet access, so that nobody from outside can access this data server. So that is what public and private subnets are. What it basically so what it basically is, it is just AWS resource to segregate the AWS resource to partition the servers or anything that you want in your like in a VPC. Now so what it does is it just logically differentiating the EC2 instances into different groups. So this is one group, and this is the second group. And this, it is having the public, it is having internet access. So it is like having all the instances which are like, which can be accessed through the internet, and it's both ways. Now in this, it does not have internet access. All the resources that you want, which should not have the access to internet, can come into the private subnet. Now after this is how it somewhere looks. So this is your VPC, virtual private service, and inside this you could have one public subnet and one private subnet. Now this is what, till now we have understand that in this, whatever EC2 instance is being public facing. Now people or internet could access these resources now. But to access or have the internet access of these two, this connection is being developed with a internet gateway. Now this is the symbol for internet IGW, which is internet gateway. Now, internet gateway is like an essential part of every VPC. Also, one VPC can have as many subnets as it wants, but only one internet gateway can be attached to one VPC. What it means is, in a single VPC, you can have a single internet gateway, and you cannot have more than one internet gateway in a particular VPC. Now, this is your VPC. You have your internet gateway, and then this is the public subnet, and in this you have your instances. Now through internet gateway you can have the access to your internet. Now you have this public subnet. Inside that you have your public EC2 instance, and this EC2 instance have the internet is accessing the internet, or the people outside the internet is accessing the EC2 instance through this internet gateway. Now just with the internet gateway you can't access your uh, internet. You There has to be route. The supposedly you there is a do You cannot like there has to be route. You have to route the traffic to the EC2 instance, and the EC2 instance to route the traffic to internet gateway. So for that what you need is route tables. Now route tables come into play. This is also one of the component of VPC. Now route table. Now what it means is, what it does is it routes the traffic. It routes the traffic or the signals from public subnet public or routes the traffic from public subnet to internet gateway, public subnet to internet gateway. But that is not the only thing that the route table does. Is everything inside a VPC is has to route somewhere. So route table, what it does is everything inside a subnet, it routes the traffic or the signals at a subnet level. Now once you know that, now that you have a public subnet, you have a private subnet, you have an internet gateway. Now route tables you have. Now you have to make route table association to it. Now what it means is that in your VPC you have your public and a private subnet, and here is your internet gateway. Here is the users. Okay, so now here is the router, what you could call it as router. Now what it does is your publics, inside this you have your EC2 instance. Now inside this, here a route table is has to be there, which is not visible, but then it has to be there. It is like an essential thing. And inside the route table, you specify some routes that this public subnet can access to internet gateway, and you could specify the target and all the routes you could specify. Let you know by will make a VPC, and then you'll be have a clear vision about it. So what it does is this route table specify the routes between the public subnet and the uh, internet gateway. Now you made a public subnet, you make a private subnet. Inside this you made a EC2 instance, which is like a web server, and it has internet facing. So you made a route table for the internet gateway to access the EC2 instance, or the EC2 instance to access the internet. So what it does is it is taking the help of routes, route table inside which you have written all the routes for your EC2 instance to access the internet through the internet gateway. Now what is happening is your EC2 instance is routing the signal to your internet gateway, but between this a route table is being specified, which is helpful. A route table is specified, which is helpful to route signals or traffic. Okay, now you know a basic components or basic things that are required in a route table. Now also you had to, now if once you make route table, This is your root table. Inside this, you have written routes. This is your subnet, and this is your internet gateway. Now you want the inside this you have EC2 instance, public subnet. Now now once you send signal directly to internet gateway, it won't work. So your signal has to be passed through the route table, and then the routes has been, or not through the route table, but then route table routes the traffic from your EC2 instance to the internet gateway. That is what is the job of your route table in a VPC. I'll show you a picture of it so that it would be more clear to you. So here is what is a picture. Next on. Now this is a complete picture of a VPC. It may be, it looks like a very big thing, but then right now what we have learned is here we have made a public subnet, we have made a private subnet. Then inside this we have a public EC2 instance, which is with the help of route table, it is routing the traffic through internet gateway. Only this part of thing that we have learned till now. Now let's just go and let's just go and let me go and make a this for you. Uh, VPC. Now I enter my sign in. Which is 3 2 an hour. Now let's go to any particular region. Right now in a Northern Virginia, let's go to US West 1 so that we could make AWS resources. Now, how if you have to make a VPC, you just go making a VPC is like a very simple thing. So you go to VPC and you can make it via Terraform as well, but then just for the understanding, here it is looks better in a clean format. You could see a default VPC in every region is being provided by the AWS. So you could see a route table is being attached to this, is ACL is attached to it, a default VPC, yes, it is a default VPC and everything. So now if you want to create a VPC, you go to create a VPC and you name it my prod VPC. Let's just name it. And the CIDR block that you want for your VPC is like you could write it 10.0.0.0 slash 16. What it means is it gives you a, VPC number of IP addresses inside your VPC, and then nothing, you just have to create a VPC. Now you have created a VPC, and you could see here by default this inside that VPC by default a main route table is being attached to it. There is, you could see there are no subnet inside this VPC, and you could see a route table is being attached to it because that is by default, that is, but we'll make our own route table. So inside the CIDR block, you could see 10.0.0.16 is what is being associated to this. Now inside this, you could also see, yeah, okay. So this is your VPC. Now inside this, you have to make your subnet. Now to make your subnets, you go to the subnet, and inside these subnet, these are the default subnets that are public and private subnet that is there. So you filter it by my prod VPC. You could see in our VPC there is no subnet. So you create a subnet and you attach it to your VPC, and you could see here the CIDR block is already being given. Now inside this subnet, I'll giving it as the name as public subnet. Now availability zone, you could launch the subnet to as many availability zone as you want, but right now only two availability zones are available in this, so we could go for US West 1A. Now IPv4 CIDR block, what you want to give is, now inside this subnet you could do CIDR block. uh yeah, okay, so this is the CIDR block that you could see is being getting attached to a subnet or your subnet. I this is the IPv your VPC IPv uh your VPC IP cider block range or IP address ranges. Then after this, you could add one more subnet, and inside this, your subnet, you could add private subnet, and then the availability zone that you could see is one US West 1A, and you could here write the IPv4 cider block range. Now this is the VPC cider range. Now for the subnet, for the subnet is just a group inside the VPC. So the IP range should be distributed from the VPC's range. Now what you're doing is you could attach 10.0.0.0/24. Now what it means is what it means, I'll show you. What it means is here you're giving 10.0.0.0/24. So last three are the things that are or last three octets are available. So the first thing that you're gonna wait, I'll show you. Uh, yeah. So so 10.0.0.0-24. So let's just take this new. So this is what the IP ranges are of VPC. Now for our public subnet I'm giving 10.0.0.0/24. Now what it means is only the last octet is empty. Now in this all now what 24 means, all this octet 8, 16, 24 and 32. Now in this only the last octet is empty. So the IPv4 range would be 10.0.0.1/24, and the last would be 10.0.0.255/24. So this would be the IP range of our public subnet. Now for a private subnet I could give. Now also you should know that the subnets IP ranges should not overlap each other. So this is our private subnet. So I could give the ranges 10.0.1.0/24. What it means is the first that you could see here, the first is 10.0.1.1. This is the first IP range, and the last would be 10.0.1.254. This would be the last IP range. So this would be the private IP range. Now let's just go and give it to our IP range. Now public subnet and a private subnet I'm giving 10.0.1.0/24. Now this is our private subnet IP range. Now let's just create our subnet. Now it is gonna take some time because the subnet is getting created. So you could see here now. Let's just and default my VPC. Now in our VPC, you could see there are two subnets, that is one public and one private. You could see here IPv4 address. Now you could see 251 IP addresses in each are available, and USC West 1 region is available. Default subnet it is no. Auto assign subnet. Now one thing in public IP, whenever we launch any resources, it should have the default IP, or it should auto assign the IPv4 address. So in my public settings, I go edit and I enable the auto assign IPv4 address. What it means is any resource that we are gonna create in our public subnet, it is gonna create a uh, gonna automatically give a IPv4 address to that particular subnet. Now after this, what we have to do is, once we have created a subnet, the second thing what we have to create is route tables. Or before that, let's just create an internet gateway. So you could see here, one default internet gateway is already there, but you need to filter it by, let's just, in my product, there is no internet gateway. So I just create an internet gateway. Let's just call it my prod internet gateway. Now I'm given it this name, just creating it. Now this internet gateway is attached. It's being created. Now I have to go and action and attach it to VPC. Now which VPC is I am attaching it to? My prod VPC. The other VPC name is not coming because one internet gateway can have only one VPC. One VPC can attach to only one internet gateway. So right now you could see in your VPC. You go to your VPC, in this you could see your internet gateway is being attached. There is uh, there is no main route table or anything. Everything is being given now, and you select this, and you could see here the VPC ID is being here, is being defined here, and then there is no route table that is being defined. This is the IPv4 CIDR range, and apart from that, in the resource map, you could see here that route tables. This is the default route table that is being given, but we'll change it. Now, this is the internet gateway that is being attached. Now, let's just go, and after this, we have to create routes for your, or let's just once your internet gateway is being done, now after that, what you should know is you should create a route table for your IPv4 range. Now I'll just go to our route tables. Inside this, you just go to the route tables, and inside this, you could see to our VPC does not have any route table. So I just create a route table. Let's just say we should create two route tables, basically one for the public subnets and one for the private subnet. But you could create more route tables as well, as many route tables as you want, but just to make things more simple and don't have to create a mess, just creating one public route table and one private route tables. So public route table, and the VPC which I am attaching it to is my prod VPC, and just create a route table. Now my route table is being created. Now there is already a default route. What this means is, you could see here, this is the VPC IPv4 range and the target is local. So what it means is okay, 10.0.0.0/16. This is the all the VPC range. Now target is target is local. What it means is everything inside your VPC, uh, everything everything inside your VPC can connect to each other. Supposedly you have a EC2 instance in your public subnet and one EC2 instance in your private subnet. So it gives access to all the resources in your VPC to connect to each other locally. Since all the things are in a same VPC, so everything can connect locally. So that is what this route table is being defining. Now let's just create a private route table as well. So you go to route tables, and under your VPC, my prod VPC, you could see two route tables. This is the route table that is being attached by default. So let's just not do it. Let's create our own route table. We would create private route table. Now let's just attach to our broad VPC and just create a route table. Now inside this, you could also see the same thing that is being associated. Now you could see subnet association. There is no explicit subnet association in both of your route tables. Now in public route table, you could also see routes and the subnet association. There's no subnet association as of now. So what subnet association is, which subnet you want this route table to get attached to. So let's just attach our subnet. So our public route table should have public subnet attached. So save association, and a private route table should have private subnet attached to it. Edit subnet. Let's just add our private subnet to our private route table. Now this is what we have done till now. Now we want to create routes. Now let's just go to our public route table, and our public route table, what it should have is, it should have the route, or it should be what it was doing is private public route table. What it was doing is, through the internet gateway, it was uh, uh, connecting it to our public subnet. So all the things in our public subnets is being routed to internet gateway via the public route table. Now let's edit routes, and inside this just add a route. Now it could be anywhere. Now here you could see you have to write internet gateway. Now I have attached my internet gateway, my product internet gateway, and I have saved the changes. Now this is the new route that we have created. What it is doing is, it is just attaching the public, everything inside the public network subnet to the internet gateway via public route table. Now This is what we have done till now. Now everything inside our public root table will have our internet access. Now after this, what you could do is you could let's just filter it by VPC. Now after you have created a VPC, after you have created a root tables, now you could see in a private root table. Let's just first let's just see that there are no roots that we have attached in our private roots. Now everything is done. Everything we have learned till now is what we have implemented till now. Now, if you launch any EC2 instance in your public root table, it will be able to access to the internet. When you launch a EC2 in your public subnet, if the root tables, if this root would, if we wouldn't have added this root, then it would not be able to, the EC2 instance and the public subnet would not be able to have the internet access. So that's why we have made an internet gateway, and in this internet gateway we have attached to our root table public subnet. Now now what you have to do is, now supposedly everything you have learned till now, there's this term what is known as bastion hosts. Now what it is doing is, what you're doing till now is, uh now supposedly, uh this is your VPC, this is the public subnet PC, this is the private private subnet. Now you have a EC2 here, you have three EC2 instances here. Supposedly your application is being launched through a private, in all the things that are available in your application, everything is in a private subnet. Now these EC2 instances don't have the internet access. Now what you could do is, a bastion host is being launched is what, it is just the EC2 instance in your public subnet, which can, now everything inside the VPC can locally attached to each other, like can contact each other. So this EC2 instance can contact these three things. So also this is in a public subnet, so it could be facing internet. So now you want to update, or now this EC2 instance is what known as bastion host. Now what it is doing is, now here are the users, and these users can, this is being, is can have access to internet. Now you want to update anything in these server, so what you could do is, you could make a bastion host like a EC2 instance which could connect to these EC2 instances, and through the internet you could go to this EC2 instance, and via this EC2 instance you could SSH into all these three EC2 instances to update anything if you want to. Now, and now there is this bastion host. What it is doing is, it is simply used to update the EC2 instances. Now what are other things that you have to mention is, take care of, that the security group. Now the security group of these EC2 instance should allow the secure, now let's just, now this is the bastion host in public subnet, now this is the private subnet. Now security group of this, of private EC2 instance should allow, now this is the security, should allow the security group of bastion host to SSH into it. What you could do is, you could go to the security group of your EC2 instance and could allow port, or could allow a custom TCP in which the source would be custom, and the destination would be bastion host, bastion host security group. What it means is, you are just letting this EC2 instance security group know that yes, this bastion host can connect to me. So this is what you're allowing. You're allowing the inbound rules of that, yes, allow this security, allow this bastion host to SSH into me. Now once this bastion host SSH into this, now what you could do is, you could just through the internet, you could just update this applications inside the private EC2. You could just once this bastion node SSH into these EC2 instances, you could update these application inside the EC2 instances. But now what you could do is this connection is two-way. The bastion host can connect the EC2 instances. Now what you could do is the bastion host itself is a EC2 instance. Now this is like a when your servers are launched in a private EC2 instance in a private subnet, then they don't have internet access. To let them have internet access, two things could be used, either a bastion host or a NAT gateway. Now bastion host is itself a EC2 instance, so you have to maintain the bastion host as well. And also this EC2 instance could access one EC2 instance at a time. Like you could SSH into a single instance. Supposedly there are 1,000 EC2 instances in a private subnet, and you want to update patches on half of the EC2 instance. So then Bastion host would not be a suitable option for you. So now what you have to do is you have to SSH into all the EC2 instances that has to update the patches. So that's like a long process. So to cut short it, what AWS comes up with, they comes up with a NAT gateway. NAT gateway. Now what NAT means is network address translation. Now what it means is this NAT gateways replace the bastion host, and it is a stateless firewall. You could even call it a firewall. What stateless firewall means, your security group for a EC2 instance is a stateful firewall. It is just a firewall. It is a protection for your EC2 instance. What is a stateful firewall is? Your stateful firewall means supposedly you have accepted a inbound rules from TCP from port 22. What it means is, yes, the internet could have access to my security group. Then the opposite of it, as in the outbound rules, will automatically be set, as in it is both ways, but you don't have to specify the outbound rule in this. Supposedly, you have accepted that yes, server A can access server B. Server B, the server B has the security group of server B. What the inbound rule says that it has accepted a request from server A. So what it means is it is also means that you have also accepted to send a request to server A. Then both of the things, it is two-way. You could see it is taking the request as well as except sending back the request as well. So you only have to specify the inbound rule. This is automatically being detected by the security group. That is why it is known as stateful. Now NAT gateway is a stateless. What it means is you could only send request. Now your EC2 instance in private subnet can nobody out from outside the internet can have access to it, but your EC2 instance can have access to it. It is that it can have only one way communication from for your supposedly your private EC2 instance, private subnet EC2 instance need to update some patches, so it needs internet. So you could launch a NAT gateway, and through the NAT gateway, what it can do is through the NAT gateway, it can go to the internet. Through the NAT gateway, it can go to the internet gateway, and from internet gateway, it can have the association with internet. So it could update everything, but nobody from here can have the access of this EC2 instance. So that is why NAT gateway is kind of important in a VPC. Now I'll show you a picture and to give you a more simpler view. So this is like your EC2 instance. This is like your NAT gateway. What it is doing is it is taking the request from private EC2 instances and sending it to internet gateway, and then sending it to internet to update everything. Now, also one thing is also, so for your Bastion host, you need to have security group to be have to be specified, and you have to take care of the security group. But for your NAT gateway, no security group has to be no security group has to be assigned or has to be taken care of. You just have to in the root table, you just have to create a root from your from private subnet to NAT gateway. NAT gateway, and from NAT gateway you could take the internet gateway. You could go to the internet gateway, route to the internet gateway, and from there you could have internet. So you just have to add a route from your in the route table, and then you could have access to your private EC2 instances can have access to the internet and can update the patches if they want to. But from the outside internet, nobody can have access to your private EC2 instances. So that's why NAT gateways are can replace the bastion hosts for your EC2 instances. Also, you have created a route for your NAT gateway, so you can create the NAT gateway to as many regions in your regions that you want. Now, okay, so let's just go and create a NAT gateway now. So I'm in my VPC, and in here I go to NAT gateway, and you could see in our VPC I have no NAT gateways that is being attached. So I create a NAT gateway. So my private NAT gateway ng. Okay, so I'm attaching it to a subnet. So right now I have my subnet. Yeah, I can launch it on as many subnets as many availability zones on as many subnets as I want. But then I want to attach it to a private subnet, so I'm just launching it to here. But if you want to have it highly available, you could launch it on multiple subnets and multiple EC2 instances. Now, also one thing, you can't launch it on your private subnet. Now, why you can't launch it on your private subnet? I'll tell you why. So, so now this is your VPC, and here you have two subnet. You have your private EC2 instances in your private subnet. So the now if you launch your NAT gateway in the same uh, subnet, then the instances of the same subnet will not be able to access to the NAT gateway. That is one thing that you have to taken care of. So if you have launched the NAT gateway in a private subnet, if you launch it or if you create it in a private subnet, then the EC2 instances in that subnet will not be able to access the NAT gateway. That is one thing. So for that, what you need to do is you could launch a NAT gateway in your public subnet. You could launch a NAT gateway here, and then in the private subnet, you could see here you have your EC2 instances. So you could create via root table, private root table we have created. So via root table, you could have access to this NAT gateway. Also, this NAT gateway is have a elastic IP. Elastic IP means that once you close a EC2 instance and create it again, your IP address keeps on changing. But elastic IP is one thing that remains same. So NAT gateway have a elastic IP. Elastic IP. Now let's just go and create a NAT gateway in our public subnet. Now connectivity, I'm giving it a private. Now allocate elastic IP. Now I have added elastic IP to it and just create a NAT gateway. Now I have created a NAT gateway. Now it is gonna take some time for this NAT gateway to make. Till then we could go to the root tables, and in our private root table we have to attach a root for a NAT gateway to connect to our EC2 instances. So what I could do is I could just go to the roots, I could edit roots, and I could create a root. Now here I could go any EC2 instances in our private subnet can have the NAT gateway, and in the NAT gateway I could my private NAT gateway. I've added it. So what it does is it is all the EC2 instances in your private subnet. Any EC2 instance can have a route to a NAT gateway. What it means is now your EC2 instance in your private subnet can have a NAT can have an internet access through the NAT gateway. Now this is what we have done till now, and you could go to the NAT gateways, and it is gonna create some time, but then this is what we have learned till now. Your NAT gateway is what is creating a EC2 instance, or is letting your private EC2 instance to have a internet access to your uh, through the internet gateway could have access to your. So now we have created, now till now we have created two subnets. Inside that we have created inside that we can create EC2 instance you want. If you not, if you don't want, you cannot create a EC2 instance. In the public we have created two route tables, one for public subnet, one for private subnet. We have created an internet gateway. We have also created a NAT gateway. Why NAT gateway and not Bastion host is because NAT gateway is simpler. It does not involve security groups. It is like it is also cost efficient. Is because in EC2 you have to take care of your EC2 instance type and everything, so the cost depends on that. But the NAT gateway cost depends on your number of or the bandwidth that it is using. Also it can go up to 45 GB of bandwidth. So that now if you use Bastion hosts, also it is difficult if you have many EC2 instances in your private subnet. So to update patches in any private EC2 instance, you could have to SSH into each individually. So that is why NAT gateway reduces the effort and also is simpler, more easy to use, and is letting your EC2 is also stateless. What it means is it is only directing the traffic one way. So your private EC2 instances can have the internet access, but nobody from the internet can have access to your private EC2 instances. So that is what we have learned till now. Now there are other things that has to be learned, which are like your security groups and your NACLs. What is NACLs is? It is just a stateless firewall for anything. So I'll tell you in the next video.